Hey, trig students. I hope you guys are doing well. I'm probably at home with my family. So told you I'd make some lessons for you, so here they are. Make sure you have your notes out. Trigonometry Unit 3 notes. Here you guys start the law of sines and law of cosines. Mr. Jurley can help you out if you guys need so, but please follow along. If you need to press pause at all, realize you guys can go back and view this again if you need to. So um, here's your assignments. Section 3.1 A, B, 3.2 A and B, and we cover the law of sines and cosines. You guys have long learned how to be able to work with right triangles. We want to work with oblique triangles. So for this first video, I want to show you guys the law of sines and how it works out. So we start with this first part. It says, many triangles that are not right triangles, but rather oblique triangles. Let's use what we know about right triangle trig to derive a way to solve oblique triangles. So if you fill this in with me, we're going to call this side A, B, and C. And if that's A, B, and C, then we have little a, we have little b, and we have little c down here. Now, if you look at the triangle, it's not a right triangle. So in order to say something interesting about it, we need to change something here. And I'm going to drop down this little spot right here, and I'm going to call it H for height. Now, as you look at this diagram here, what we're going to do is we're going to try to write two interesting trig equations that involve A and B. You're going to start with sine of A is equal to, and sine of B is equal to. If you look at it, we made a right triangle. The right triangle is right here, or right here on that side. So being we made a right triangle, you could see that we could say that the sine of A is what? Yeah, H over B. H over B. And the sine of B, sine of angle B would be, yep, H over A. You guys can respond in class when I ask questions, even though I'm not here. And so there you go. And if you look at these two expressions up there, sine of A equals H over B, and then sine of B equals H over A, as you notice, they both have an H in common. And that's going to be useful for us to write a new expression. And the new expression looks like this. If I want to solve for H, I'll multiply both sides by B. So we have B times the sine of A is equal to H. And we also have A times the sine of B is equal to H. Now I'm going to ask you guys the questions that you know the answer to, but if they're both equal to H, then they're both, yes, they're both equal to each other. Very good. I know you guys got that. B times the sine of A is equal to A times the sine of B. And that's what you have. Now, your book actually writes that relationship between sides and angles in a little bit different fashion. And the way that it writes it is like this. It divides this side by B and this side by B. And it also divides this side by A and this side by A. So if you look, the B's cancel here, the A's cancel here, and you're left with the sine of A over A is equal to the sine of angle B over B. And that is, in essence, the law of sines. The law of sines is very, very useful if you go down to this bottom part, as it says a law of sines here. And what it says is if you're given a triangle A, B, and C with sides A, B, and C, then you know this is true. The sine of angle A divided by side A is going to be equal to the sine of B divided by side B, which is equal to the sine of C divided by side C. And the key to making this work out is this phrase at the bottom. It says you must be given an angle and its opposite side. I know it says and, but you must be given an angle and its opposite side in order to make this work. If you don't have an angle on one of the opposite sides, you can forget about it. So for example, you either need angle A and side A, or you need angle B and side B, or you need angle C and side C. You need an angle and its opposite side, and then it works out. As we flip over, you guys are going to see how this works out, but we'll stop this first video right now, see how it goes.